Right, good evening, guys. Thank you very much for coming by. Today is kind of like a Friday for both of you guys as well. So, just prior to starting today's talk, very welcome to the first event of Ethereum Singapore for this year. We started this group out 2 years ago in 2015, and the theme back then was more about awareness, for getting people to know a little bit more about Ethereum, about blockchain technology, and what it can really do for you. And we brought the EF back in June in 2015. They came by for a 2-day workshop, talked to a lot of people about it, did a demo day. Things got really interesting then. Then last year, I think the focus last year for us at least was all about educating. It was an educational focus of the year of events. So we had a lot of use cases of people coming around, speaking about what they can do with the technology itself, but not really too much about application. So for this year, 2017, Ethereum Singapore is going to put about a theme all around the world of application. We're looking to invite you guys, if you have any interesting startups right now that you're looking to develop on Ethereum, you're looking to find an application for it, you're looking to find something to apply to, just let us know. We're going to be opening up a speaking slot called Demo Day and Workshop Display. So the very first one that's coming up will be on 2nd of March, where Digix as well as Taurus and Autonomous will be speaking just on what they are doing on their own frontline, as well as what an open source community-based project on Ethereum could look like. Yeah, so a couple of events are coming up this first quarter. It's quite a busy period. We have one on 8th of February. It's by Bitcoin Singapore, where there will be the topic will be about atomic swaps using Lightning Network. The speaker here, Toby, he'll be speaking this. So if you want to find out a little bit more about the event next week, you can speak to him after this event. And on 22nd of February, there will be an inaugural blockchain night at SG Innovate. It's a new hub based off 32 Carpenter Street. So SG Innovate has right now incubated a couple of startups, including ourselves, Digix and Taurus. And SG Innovate is a wholly owned Singapore government entity that's backed by the Ministry of Finance. It's a pretty cool space. A lot of innovation ideas are going on right now there. And the next event, which is the startup trio, the Digix, Taurus, and Autonomous will be speaking on the event. Right. And in April, there will be an event called BlockCon. BlockCon will happen on April 25th to 26th. It will be held at Lattice 80. It's all about a focus on re-engineering finance. It's all about blockchain. The event organizers by Singapore FinTech Consortium, Mona and Gilbin. I believe they are somewhere in the room. Yeah. So if you want to find out a little bit more about the event, about what can it really do for you and what it will interest you about, feel free to speak to them after the event. And last but not least, we need to thank Microsoft here for actually giving us this space on a good time frame, as well as providing us pizzas on site. So yeah, and hope you guys have already had the pizza. And yeah, pretty much just a bit more for this year. And yeah, Vitalik has a lot to talk about Metropolis. So Vitalik,
Okay, great. So first of all, just to kind of gauge the audience, how many people here have heard of Ethereum before? How many people have heard of 12th degree extension fields before? Oh, cool. One hand raised up there. How many people have heard of EIP86 before? A few. Okay, that's good to know. So just to, I'll start off by giving a kind of general update on where Ethereum has been from a technical perspective, how much we've done over the last half year or so, and from there move on to kind of what Metropolis is and the kinds of major changes that we're planning and minor changes that we're planning to add in with it, kind of what our goals are, and generally how it fits into our roadmap. So, ongoing progress, there's been quite a lot over the past year. So this last year in the summer, we obviously had the DAO situation, then the DOS attacks, and that did end up diverting our kind of attention to some extent, because basically we realized that we had to take this big long detour working on just improving the core client efficiency, working on security, making sure that all of the holes in the clients are fixed, and we spent quite a lot of time doing that. And I think in general we've had fairly good results. I mean, Ethereum clients generally the Ethereum virtual machine's been improved by 40%. Almost finished working on ways to make input and output from the state much more efficient, make fast syncing even faster, and lots of various other things. So there has been a lot of kind of that kind of fairly kind of technical and incremental work that's been happening in the summer and in the fall. For the last couple of months, the situation with the attacks finally kind of settled down, and we've been starting to kind of move much more full force on actually getting moving forward on improving the protocol and going toward Metropolis. So that's on the client side. Whisper and Swarm are two of the kind of sister protocols to Ethereum. So Whisper is kind of peer-to-peer messaging. Swarm is kind of peer-to-peer kind of file storage in kind of a very primitive sense. And both of these are all moving forward themselves. They all have their own roadmaps. Whisper is now at version 5. Swarm is in alpha. There are people starting to build applications on top of them. So like this is an example of a kind of decentralized bulletin board using Swarm. There's also independent groups starting to work on Ethereum mobile clients. Basically, the Ethereum Lite client kind of library was released in alpha a few months ago, and it's been also getting better and better over the last couple of months, which basically means that finally you don't need to download the entire Ethereum blockchain in order to interact with Ethereum. Now, this sounds fairly trivial, but it is fairly important because the Ethereum blockchain, is somewhere between 5 and 20 gigabytes in size, depending on which client you're using. And that's probably okay for your for a laptop, but not very okay for a phone. So our developers were working hard on building this light client library that lets you securely access only kind of and verify only the small pieces of the blockchain that you personally are interested in. And the result is like there's mobile phone applications like Status, for example, is integrating it. They're also planning on integrating Swarm and Whisper, and generally kind of lots of action happening in terms of making Ethereum more usable on phones. And hopefully that's also something that'll make it much more interesting to like people in places like China, here, kind of mobile phone centric emerging economies generally, and just make it more convenient for everyone else. So that's a kind of track that's been happening in parallel. So now, alongside this, there's obviously been a lot of various smaller things, improvements on Mist, improvements in security, improvements in high-level programming languages, particularly improvements in safety, making it easier to write smart contracts that don't have errors in them, and lots of other small things. So now that a lot of that is finally starting to be behind us, we can look forward and start to see what, and kind of start to plan ahead and starts to implement implement the things that we have been planning ahead for a while in terms of the next 1 or 2 versions of the protocol. So there's quite a lot of interesting stuff that a lot of this is admittedly fairly technical, and it is like quite a lot of this is fairly kind of these kind of small incremental and dry changes, which I've tried to make slightly more entertaining by making funny pictures beside them. But I'll probably summarize by saying there's a few major goals behind the things that we're trying to do here. So one of them is this principle of abstraction. And abstraction basically means try to make the protocol itself as simple as possible, and instead let people use Ethereum's virtual machine to kind of do as much as they need to. So one example right now is that with EIP86, basically the goal is to try to abstract away transaction signing, so that instead of there being one particular way to sign transactions, one particular way to secure accounts, people can kind of configure their own accounts and specify how transactions from their own accounts get signed and they can specify whatever logic they want by writing it in code. Also, one nice side effect that'll end up coming from this is that any account in a call execution chain can pay for gas. So not just the sender of a transaction necessarily, also potentially the recipient of a transaction, potentially some contract in the middle. And this is very nice for like convenience for various kinds of applications. It also has privacy benefits. So like a lot of the privacy enhancing technologies that I'll be talking about later on, they actually like they actually do really depend on this, because in a lot of them, if you try to implement them naively, having to have one account that you use to pay for gas often ends up being a kind of de-anonymization vector. So this will hopefully improve that situation. Basically here, just fairly technical change. The goal is to try to make it easier to process transactions in parallel. This basic EIP 96, basically the goal here, in very simple terms, is to try to make light clients more secure. Security upgrades, then big integer precompile. So the idea here is to try to make it easier to verify certain types of cryptography that are kind of already standardized in various other contexts. So like, Ethereum, the kind of cryptography that's supported in Ethereum right now is elliptic curve cryptography, but there's a bunch of other applications on the internet that use RSA. And right now, verifying RSA inside of Ethereum is just computationally fairly inefficient. So we're planning on introducing some like various optimizations to try and make that much faster in fairly simple terms. Static call, so this is also kind of, once again, all this is like still under consideration. But basically the idea here is just a way of calling a contract where you just wants to get information from it, and you want to be sure that like you're not changing any state, you don't have any reentrancy issues, you don't have like any kind of any of those sort of safety concerns that we saw in the last year or so. And so like basically if you're calling a contract and you know that you're making a call that doesn't need to change anything, then you have this special kind of opcode that lets you be sure that you're not going to change anything. Pure call, that's kind of an even more static version of static call. Not only can it not write, it also can't even read. Throw opcode, so basically this is just like a somewhat cleaner and more efficient way of doing exceptions. Invalid opcode. So lots of kind of small changes like that. Personally, out of the ones so far, the kind of abstraction roadmap is probably the thing that interests me the most. But that's more from kind of my point of view as a developer and as someone who wants to have more ability to kind of tinker around with things without making your applications unnecessarily inefficient. But the other kind of flagship features that we're really thinking about and really considering also have to do with privacy. So like a lot of the time when people ask about the Ethereum research roadmap, the three things that I generally tell people we're focusing on are number 1, privacy, number 2, scalability, and number 3, safety, right? So basically the three reasons why, like the three main categories of disadvantages I would say blockchains have over other more traditional ways of doing things. So just as a recap, like privacy, basically the challenge is you got your blockchain, very public kind of database-like thing that anyone can read, but the problem, and because anyone can read it, anyone can verify it, but at the same time, because anyone can read it, so you don't have privacy. So the question is, how can we kind of get more privacy for Ethereum-based applications without sacrificing the security, without sacrificing the ability to verify that everything's being done correctly, without sacrificing the people like having guarantees about code being executed in the way that they expect it'll be executed. And it turns out there is actually quite a lot of ways to at least accomplish this to various extents. Now, you can't really get perfect privacy, but there are a lot of ways to kind of chip at the problem on the margin. And a lot of the time when I talk about this, I talk on the one hand about kind of low-tech strategies. So these are just strategies that try to either be very careful about how you use the blockchain, or try and like make information encrypted if at all possible, not stick information onto the blockchain if possible, if you are putting information onto the block, like try to use off-chain mechanisms where you can. And there's also high-tech approaches. And high-tech approaches basically mean use advanced cryptography so that everyone is still verifying everything, but they are somehow magically verifying anything in such a way that even though they're verifying that things are being done correctly, they have no idea what's actually happening. And believe it or not, yes, you can actually do this. So that's where... So we start to get into fun stuff like ZK Snarks. So this is probably a fairly hot topic in cryptography over the last year. I mean, one major reason why it's a hot topic is because Zcash was launched about 2 months ago, which is basically a kind of cryptocurrency whose flagship feature is that it integrated this. So basically, ZK Snarks are kind of the ultimate in privacy. And you can think of it as kind of proving things about encrypted data without revealing anything about the data except for the claim that you're proving. So one very simple example I have here is if you want to have like a cryptocurrency on a blockchain, but you don't want people's balances to be visible to everyone else, then what you do is you store people's encrypted balances on the blockchain. Now, let's say that I want to send a transaction. Then the transaction amounts are also encrypted. Now, the problem is though, of course, that you can't just like let people set their balances to whatever encrypted data they want, because then people can just give themselves free money. But then, so you do have a kind of correctness claim that you want to verify, right? So the correctness claim basically looks like this. It basically says, if I am sending a transaction, the amount I am sending should be less than or equal to the amount of money I have. Makes sense, right? Not too technical for people. And the new balance should be the old balance minus the amount that you're sending. Okay, so problem is, how do you actually check this if all these numbers are encrypted? Now, basically the answer is that the owner of the account and the sender of the transaction, who has the decryption key, and who does know this themselves, can create this magic cryptographic thing called a ZK Snark. And this basically is this kind of cryptographic proof that other people can use to verify that this computation was performed, and the result of the computation says that this check is true, but without knowing anything else, without knowing anything about the encrypted numbers. Right? So that's, so like in some ways, ZK Snarks are kind of this sort of super protocol that lets you do like a huge generalization of like many categories of things that cryptographers have been trying to do over the last 30 years. So it's potentially a very powerful technology, and like Zcash basically is using something similar to this. I mean, with kind of a few complexities attached on their own, but like that's the general principle. So basically what we want to do for Ethereum is we want to use this kind of approach, but generalize it to things beyond just currency transactions, right? So ideally, this doesn't need to just be like an encrypted balance check. It could also be you have a contract, the contract's code is encrypted, and the transactions are encrypted, and you're verifying that the contract in general is executing according to the logic that it's supposed to be executing under, but you prove all of this without revealing what the transaction says, without revealing what the contract says. And you could also imagine using this for something like voting, where you don't want to reveal like exactly what every single person voted for, but you still want to verify that the results are correct. So the technology is good for that too, and there's a bunch of other applications. If you're thinking about like digital identity systems, then this technology is cool because you can verify like fairly complex claims about a person, like this person has some certification from one of these entities, and this person was born after July 17th, 1984, and something else. And you can just like create that kind of claim, make a ZK Snark that it's true, without revealing any single thing except for that, right? So, I mean, one slightly mean application that some regulated businesses tend to love is that you can use this to make a fully anonymous proof that the person you're interacting with is not a U.S. citizen. potentially, once you actually have kind of the registrations for like all the other, like some kind of digital identity for all the other countries. But we're actually, especially with Estonian residency IDs, we're getting close to that. So the weaknesses, so this technology is amazing, so why isn't everyone using it already? I mean, one reason is that it's very new. Like, it's, like, the general concept has existed in some form for about 20 to 30 years, but it's only really become viable in the last, like, 2 or 3 years. And the number of people that understands the technology is still kind of fairly small. And I think, in general, probably the blockchain space is, like, the first major use case for this stuff, right? So, but there's also other fundamental weaknesses of the technology. So one of them is this kind of trusted setup that, by the way, how many people here have heard of the trusted setup? Okay, some. Well, so this is like a limitation of this particular technology. Basically, the idea is that creating one of these proofs and like verifying these proofs requires this kind of access to this key, a kind of setup key. But the setup key has to be generated. Now, the setup key has to be generated by someone. Now, the process of generating the setup key involves a bunch of secret information. Now, the secret information is not part of the setup key, but the person that created the setup key has this secret information, and if what they're supposed to do is they're supposed to delete the secret information, and if the secret information is deleted, then the setup key is fine. You can like go ahead and like use the secret key for all these ZK Snarks, and it's okay. But if they end up not deleting the secret data, then they could use the secret data to create invalid proofs. So like, now there are a bunch of ways of mitigating the problem. Generally, they involve like instead of involving one person to create the secret data, they would involve like a large group of people, and the idea is that all of everyone in this large group of people would need to all simultaneously kind of dishonestly not delete their secret data in order for there to be a problem. But so like you can really mitigate the problem, but at the same time it's not perfect, right? So that's one weakness. Another weakness is it takes about 40 seconds to generate a proof. So, and that's just like on a computer, and you know, on something like a smartphone, you can imagine 5 to 10 minutes. So, probably the most realistic way of mitigating this is just by making application-specific integrated circuits for it. So, just like making specialized computer chips, and given that specialized computer chips have been fairly good at making Bitcoin mining 10,000 times faster, you can imagine specialized computer chips might be pretty good at making proof creation faster as well. Not the same, so it's also important to note that this is not the same as obfuscation, and one important property is that, at least with the way this works, like if you have some kind of encrypted system or some kind of encrypted contract or whatever, someone has to have access to the decryption key, and only the people that have, and in order for someone to be able to create proofs and like kind of move the state of the system forward, that person has to be one of the people that have the decryption key. So, like, you can't basically you can't kind of build systems that have sort of no owners in some sense. Like, you know, or in some kind of very weak sense. So, this, to some, like, is a weakness to some extent. And there are ways of mitigating it, but, like, it's still a challenge. So, but, like, even still, it's extremely powerful technology, has lots of potential, and, like, the weaknesses are being kind of chipped away at by very smart people as we speak. So, like, a year ago, this wasn't 40 seconds, this was 90 seconds. So, good luck to them. Last year in July, we had a workshop in Cornell with the wonderful people from IC3 in the US, and there was also our team, and there were also a few people from the Zcash team, and we worked together on this project called Baby Zoe, where the Zoe stands for Zcash on Ethereum. And basically, this is like an integration of ZK Snarks into Ethereum, and they did it, and it worked relatively well, and people were happy. Now, of course, it's been 6 months, and we want to make people more happy. So, how do we make people more happy? Basically, well, right now we're moving forward on going from the baby Zoe prototype into something that was actually kind of is more realistic and makes more sense for like actual integration into the Ethereum protocol. And basically the idea is that in order to keep things simpler, we're not integrating the entire ZK Snark verifier directly. All we're integrating is the most computationally intensive component of ZK Snark verification. So that's something called an elliptic curve pairing, and in fancy math, you usually use the letter E, so you can see the letter E over here, over here, over here. It gets used in about 10 places. So basically, we would have one pairing for these like E checks, and it would get called around 5 or 6 times. So that's kind of the general path we're taking. Now, what are pairings? I mean, one answer is it's complicated. If someone wants to, they can look it up. So that's probably the one of the sort of flagship technical features that, once again, is being considered. Although, I mean, there's right now a lot of developer attention on trying to see on kind of trying to get this sort of standardized and coordinated and implemented. But like as usual, it's not the sort of thing where we can kind of promise timelines yet, and like so far there hasn't really been kind of full 100% agreement on finalizing most of this, right? So like so far, like all of these changes that I've talked about are things that like 80%, more than 80% of the kind of core developer community are happy with, and like no one seriously opposes it, but not finalized yet. And hopefully it will be finalized over the next few months or so. So timeline. So it's there is one external factor that is kind of influencing our decision in this case. So the Ethereum Ice Age. So basically the idea is that there is a feature that in the protocol that basically makes the Ethereum blockchain kind of blow up after some amount of time. And the reason why we put this in is that we saw what was happening with Bitcoin, where basically there's this huge pressure toward kind of the default and toward not making changes to the protocol. And there were things right from the start that we wanted to do. So like a switch to Casper, a proof of stake algorithm is what was one of the major ones. There are other things. And we wanted to really avoid this situation where there's just like so much default pressure that like changes never happen. And so what we basically said is, okay, we're just going to make the default rules of the protocol such that the blockchain blows up on its own in about 2.5 years. And that way, I mean, obviously in reality the blockchain is not going to blow up, but the reason is that the community is going to have to coordinate on some kind of change. And so it's not going to be a question of do we change something or do we not change something. It's going to be a question of do we change A or do we change B. So basically, if nothing happens, the Ice Age is slated to start happening in 3 to 6 months. Basically, right now the block time is about 14 seconds. In 3 months, it'll be about 15.8 seconds. In 6 months, it'll be about 28 seconds, and it'll kind of keep going up from there. So one of the features of the Metropolis fork is going to have to be to basically delay the Ice Age. So basically, what this means is that there actually is a timeline for Metropolis, and but the variable that's more uncertain is basically the number of features that's going to be included in it. Right. So like if there's a time crunch, we'll basically have to compromise on including only the most important ones in the list, and leaving the rest of them either for the fork after that or for like some change in some other fork in the middle, maybe 6 months after Metropolis itself. So, what about Casper? So Casper is kind of Ethereum's proof of stake algorithm. So for those who aren't aware, basically proof of stake is kind of an alternative to proof of work or mining as a consensus algorithm for blockchains. The reasons why we're interested in it are, number one is that it's cheaper, so it doesn't require kind of computers burning as much electricity or hardware. Another is that it has nicer security properties. So like if we were to go up against an extremely rich attacker, then basically it would like proof of stake kind of would give much more sort of asymmetry in the blockchain's favor. Whereas with something like proof of work, if the attacker can come up with more hash power, more hardware than you have, then basically like they can just keep on attacking you for as long as they want. So, and like various other small properties. So like this is probably one of, or also like a very major research project. Like I would even say even more important than the ZK Snark research. So the question is, I mean, I've talked a bunch about privacy, I've talked a bunch about abstraction, I've talked a bunch about throw opcodes, but you know, what's going to happen to Casper? So first of all, Casper is still happening, right? So there's been work by myself, there's been work by Loy Lu, there's been work on quite a few other people, and you know, people are moving forward in like several research directions. So the general approach that we're trying to take is we're trying to look at things from the perspective of traditional Byzantine fault tolerance theory, from the perspective of mechanism design, and like several other views at the same time, and see if we can come up with a protocol that kind of merges most of the properties that we want out of these kind of mechanisms that already exist. So PBFT is this kind of very standard algorithm that's been used for like fault-tolerant distributed systems for about 2 decades now, and it has some nice properties. It's also one of the simplest algorithms that has the properties that we want. But the goal is that we would basically have to convert the insights in that protocol into the kind of public economic blockchain setting. So what exactly does that mean? It means a few things, right? One is that you have to have incentives. And you need to have 2 kinds of incentives. One kind of incentive basically says validators get paid more if the blockchain performs well, and validators get paid more if the blockchain performs well because of what they're doing. Validators get paid less if the blockchain performs badly because of what they're doing. And particularly if the blockchain breaks, so if there's a 51% attack, if there's a fork, then because of the rules of the consensus algorithm, we would be able to know who is to blame, and everyone that we can blame, we would basically destroy their deposits. So in order to participate in Casper, you would need to buy up some amount of ether and participate as kind of a validator in the system. And if it's proven that you tried to like act in some way that would break the system, then basically your deposit is like completely destroyed. So think of it as kind of like mining, but where your mining farm burns down if you try to do anything evil. That's roughly the goal. Now, mechanism design, there's a bunch of interesting challenges here. So one challenge is, okay, if you unambiguously know who's at fault, then you can obviously just like kill them completely. But what if you know probabilistically who might be at fault, and you know that there's like 80 validators here who might be at fault, but actually only 40 of them are at fault? Then it turns out the optimal thing to do is to punish all of them, but only slightly. There's also work being done by Vlad Zamfir, one of our other researchers, on what he calls correct blank instruction consensus. So research is moving forward, and in general, Casper is definitely kind of a year behind schedule at least, but at the same time, it's also a year more advanced in terms of the properties that it has. So all in all, I think we're generally fairly happy with the progress. So the roadmap basically is, finalize the protocol, then run a testnet with it, verify the protocol, try and like examine it, have various people check that it's doing what it's supposed to be doing, then implement it across the various Ethereum implementations, continue testing it, and eventually once it's ready enough, then we plan to release. Right? So this is the sort of thing that's probably expected to take roughly a year or so. So it's this is a fairly kind of substantial undertaking, but at the same time, I think like the benefits of proof of stake are fairly large. And the other thing is that proof of stake in a lot of ways is a stepping stone to things that we want to do in the future around scalability, around like some of our sharding protocols, around like improving protocol economics. So after this, there's still quite a long roadmap to go, right? So I think like in general, we've probably already come up with like 3 to 5 years worth of things for us to do, but there's still the challenge of actually doing them. On the kind of less technical side, we've the Ethereum team itself has been expanding over the last year. We've had in several major events, like we had DEF CON 2 in Shanghai. We have started to have multiple kind of workshops and like various collaborations with academia. So like we had that boot camp with researchers at Cornell in July. I recently came from a boot camp with like some of the same researchers and some Chinese researchers from Jiao Tong University in Shanghai. So that, and we've had people like Loy Lu from NUS do some work for us. So like in general, we're kind of stepping up our collaboration with the universities on a lot of these research problems. In the future, we expect our kind of research efforts to continue growing, and if anyone feels that they're interested and they want to kind of continue and feels like they might be able to contribute, then feel free to like contact any of us. And like research has several directions, so like Casper, scalability, protocol mechanism design. At the same time, we've obviously stepped up our focus on things like privacy. We're collaborating with the Zcash team on that, also collaborating with academics. From the point of view of the kind of Ethereum ecosystem in general, I think there has been quite a lot of applications that have been moving forward. Obviously, one thing that I'm also quite happy about is the fact that we're increasingly at the point where we have third-party companies actually developing applications that are kind of basic infrastructure in some ways. So, like, there's one application called Uport, which is basically a kind of blockchain-based sort of decentralized identity management system, and that's reached its alpha, and that's something that could be used for, like, basically as a kind of login and authentication system and just as an identity layer for like a bunch of Ethereum applications. Mobile clients, Status has been doing fairly well, launched its alpha fairly recently. There's, obviously the Parity client is continuing to do good work. And so, like, we're at the point where, like, even Ethereum core developers is a substantially wider category than just people employed by the Ethereum Foundation, and that's, at least in our opinion, that's a fairly substantial. That broadening the community is something that's always good. Another thing that we're trying to move forward on, also on the less technical side, is as part of one of the things that we want to see is kind of more decentralized governance. So we want decisions on the protocol to have to be the result of input coming from more people, and not just be like 5 people that have been like part of the Ethereum project and the foundation for the last 2 or 3 years. And that's it's Ethereum is a decentralized project, and we do want kind of all layers of the project and the ecosystem to be as decentralized as possible. And that's but one of the things that we realized is it's fairly hard for people to contribute unless they know what's going on, unless they know what the different design considerations actually are, unless they actually have an idea of the various trade-offs of what the challenges are, what should be done, what are good ideas, what are bad ideas. So we have been starting to kind of substantially ramp up our educational efforts in that regard. So like I've written quite a few blog posts over the last couple of months describing like various design trade-offs in Casper, various details of how zero-knowledge proofs work. Vlad has done a series of posts on the history of like how his ideas around Casper. Like Christian, who's leading the ZK Snark effort, has started to kind of make some posts explaining things from that side. So that's something that we're kind of starting to really pay much more attention to, and also we welcome feedback, and we're really trying to ramp it up. Also, Ethereum team continues to kind of become more international. So we have lots of people in Europe. We've had people in Canada. We have people in the U.S. So one developer in China. We've had people in Singapore, and hoping to get more people in Singapore. So that's also been kind of moving forward. So on the technical side, I think what you'd probably expect to see over the next few months is us just kind of continuing to push forward on like all of these, potentially deciding that some are best left until later, but hopefully moving forward on as many of them as possible, and eventually Metropolis getting released, and hopefully with a lot of progress on the various parts of the Ethereum ecosystem alongside that, and hopefully in 6 to 12 months, like Ethereum will continue to kind of mature and be a kind of much a greater and higher quality blockchain and ecosystem than it was before. Thank you. Mm-hmm. Mm. I think, which one? I think, first of all, like, it really does depend on what your definition of decentralization is. Like, that's actually one of the things that I have, like, a blog post that I'm slowly kind of planning on writing about over the next couple of weeks. But, like, generally it's a hard problem because there's different kinds of decentralization, and, like, with consensus protocols, like, some of the variables that you have to care about is, like, number one, what is the number of participants? So, like, do 3 people control 40% of the hash power or 40% of the stake? Then then there's another variable, which is how well can it, if an oligopoly does exist, how well can it handle it, right? So, like, in Bitcoin, for example, there's the selfish mining attack, where if you have a collusion of more than a third of the mining power, then they have the incentive to try and, like, organize together and, like, basically screw over everyone else. And, with Casper, we're trying to design the protocol in such a way that it doesn't have those kinds of incentives. Another kind of decentralization is also just, like, how easy is it for regular people to participate? So how easy is it for regular people to do things like running nodes, to be validators? Then another one is obviously the trust model. So, like, in the case of proof of work, it's, just like pick the longest chain. In the case of proof of stake, it's this somewhat more complex thing where you would have to first find what the tip of the blockchain is, and then after that keep the tip updated, and you have to make sure you stay logged on or log on at least once every 2 to 4 months. So I think first of all, it definitely is the case that proof of stake is weaker than proof of work on at least some dimensions. So, like, the fact that you have this kind of slightly more intricate trust model that involves logging on once in a while and, like, getting an initial sync from somewhere, it continues to be an issue. But we are continuing to discover various ways of mitigating it. And at the same time, I'd argue proof of stake is also, like, stronger than proof of work on other dimensions in terms of being decentralized. So being able to handle all oligopolistic markets is, like, probably one example. So I think the answer there is it's fairly complicated. Alongside decentralization, the other thing that people obviously have to worry about is security. And there's different ways to define security because there's different models, right? There's different models about like what attackers are willing to do, what regular users are willing to do, what regular users are willing to do if you bribe them, what the budget of attackers is, and we're definitely trying to like push on those boundaries up as much as possible. I think once we figure out proof of all of the various details fully, I think there is going to be several kind of shifts in the ecosystem. One of them is that with proof of stake, it becomes viable for substantially smaller blockchains to be secure and to survive. So one of the challenges with proof of work is that like very small blockchains can easily just get attacked by miners from very big blockchains, and this limits the number of blockchains that can like practically survive and be secure. And whereas with proof of stake, you don't really have this effect at all. So that's one effect. And you would probably, I think, in general, see more diversification. Another reason why you'd see more diversification is that with proof of stake, you would see much lower issuance rates, and this would this would basically mean that like all of these assets become more deflationary, and so that to some extent like makes all of them more viable in some sense, and probably increases the increases the market for them. So that's one other way that it'll affect things, that'll obviously like affect the mining market, because well, miners will have to switch to doing something else. And there are other things that miners can switch to doing, right? So like I hope that if things like Swarm and if things like Golem and like computation markets, storage markets, if all of those do well, then I'm hoping that miners will just be able to like immediately switch jobs to start like participating in those networks. But that'll require like those systems to actually be kind of built up well enough for like lots of people to be willing to use them. Yeah.
If one of the goals of Casper is in general to reduce the needs of mining and proof of work that is very energy ineffective, what is the trade-off then with introducing ZK Snarks that you say could be done by ASICs and then computational?
So it's important to note that the computational cost of mining is vastly greater than the computational cost of like all these nodes doing all this verification, right? So like the Bitcoin blockchain, for example, like it burns somewhere on the order of $500 million a year, and the Ethereum blockchain is around 1/10 of that. So it's meanwhile, if you think about nodes, like Bitcoin and Ethereum both have around 10,000 nodes each, and like each node running actually really isn't necessarily all that much. So like in general, if you're talking about efficiency, I would say kind of mining costs are like issue number 1, and consensus verification costs are issue number 2. The second thing I'd point out is that for ZK Snarks, I'm not advocating using ASICs for verifying proofs. I'm advocating using ASICs for creating proofs, right? So first of all, it's only one node that we need to create the proofs. And second, like the actual cost of it is like relatively bounded. So I would expect that with an ASIC, like the chip could probably end up costing like less than $50, and I could totally expect the electricity cost of making one of these proofs to be like less than 1/100 of a cent, right? So like it is fairly low. So like ASICs aren't kind of evil, right? All they are is just specialized hardware. It's like using them for these kind of like specific forms of computation that just happen to be normally too impractical, but that could use like 1000x speed up is like I think the perfect use case. Yeah. I have not heard of a Singapore-based group called Quantum. Oh, that one. Is that Singapore-based? I thought it was China. Yeah. Yeah, I haven't looked at that too deeply yet. Yeah. There's a few possibilities, but so one possibility is to try to make it a smooth hard fork like the previous ones. There are advantages to that, but in my opinion, there's also serious disadvantages, because you'd also have to design the transition, you'd also have to audit the transition, you'd also have to design the the fork choice rule for the transition, and like you also get technical debt. The other approach is that you would basically at some point just start a new blockchain from scratch, and the state of the new blockchain would start from like the state of the existing blockchain at some point. So like you'd have it would still be fairly smooth, but you'd have a bit more of a clean break, and like that could potentially like reduce technical debt and like other kinds of overhead in a lot of ways. Then another possibility is obviously to run the two alongside each other as like side chains. At this point, like this hasn't really yet been fully agreed upon and finalized, but those are probably the general possibilities. Yes.
Ethereum Enterprise and Ethereum as a public blockchain.
Mm-hmm.
You just released a paper on
Mm-hmm.
interoperability.
Yeah. Sure. So first of all, like Ethereum Enterprise efforts, like there's been a set of efforts, and like some of them are coalescing into like an initiative that should be like announcing fairly soon, or basically trying to use Ethereum technology in enterprise contexts. So what this means in practice, like in a lot of cases, it's basically consortium chains that are Ethereum in every way except they use a different consensus algorithm. And the idea is that it would be a consortium chain, it would be a private chain, and would have those properties, but it would be like basically maximally compatible with Ethereum, and you could use Ethereum contracts on it and the other way around in as many ways as possible. And that's one aspect, but like there's obviously also like a few uses for public chains in enterprise, in which case the focus would be things like interoperability with existing systems, like standardization and so forth. As far as interoperability goes, I think one of my conclusions from that paper is that it's still a bit early to really think that hard about interoperability, because in order for interoperability between two blockchains to make sense, you would have to, number one, have blockchain A be mature enough that it actually has users. Number two, blockchain B should be mature enough that it actually has users. And C, you need to have a reason to connect the two. And like at this point, the number of blockchain applications that actually have users is fairly small. And so I don't feel like we're really at that critical mass yet. We're making those bridges is in most cases cost effective, but I think within like 1 to 2 years we'll start getting there. And like in that paper, I talk about various ways that you can actually connect blockchains. I talk about things like hash locking, and these are things like relays. And these are fairly generic tools that you could use to make applications that kind of live across many blockchains. So I think it's doable, but look, there are some unique constraints around like asynchronous programming and around like how to deal with security issues and how to deal with hard forks that would also need to be handled. Yes. Mm-hmm. Right. Okay. So rootstock is basically a kind of semi like a kind of consortium chain with the base token being backed by Bitcoin in some sense. So like if people really want to use Bitcoin inside an Ethereum like platform for whatever reason, they'd be able to do that. Although at the same time, if that's a very valuable use case, you could also just like build a very similar thing inside of Ethereum too. So like if that's, if there's demand for that, then there will be demand. Then people will use that. With a lot of these other platforms, I mean, some of them tends to just like some of them tends to take the EVM and try to like make various modifications to it, or to make like modifications to the environment that it lives under. That said, obviously, the fact that they made modifications totally does not imply that those modifications are good. Sometimes they're good, sometimes they're interesting, sometimes they're just not good, sometimes they really depend on the trade-offs. Some of them try to kind of make new virtual machines from scratch. In those cases, in a lot of them, I'm fairly skeptical because, I mean, first of all, like the effort it takes to actually create the tooling and create the ecosystem is fairly large, and even though you can say that you get benefits from like having a virtual machine that's formally provable in some sense, like there is also enough efforts that try and like implement that kind of functionality on top of Ethereum as well. And so, like one example is that some projects talk about a virtual machine where the programming language is decidable, and which like basically means that you can mathematically prove that it executes within some number of computational steps. But about 2 months ago, I released like an early version of something called Viper, which is a high-level language that compiles down to Ethereum code, but where Viper code is decidable, among a whole bunch of other safety features. So, like the thing is that Ethereum is Turing complete, and that does mean that there are relatively few things that you can do, like not on Ethereum, that you can't just like bolt onto Ethereum itself. So like but at the same time, like a lot of those projects definitely do have things you can learn from. Yeah. You can look forward to Metropolis, and Metropolis will be great. Yeah. I think actually from a kind of investor and trader standpoint, you'd probably be like also like very interested in the various projects that are being done on top of Ethereum, and a lot of these projects tends to have their own opportunities for financially participating in them in various ways. Like there's interesting things like MakerDAO that's like trying to create this sort of like a stable coin, and like if you want to invest in it, then basically you can like take these you can kind of get volatile tokens that sort of absorb the volatility from the people that want the stable coin, and that's like something that people might be interested in like having. I mean, there's like, and obviously I don't really there's other various projects, like there's various assets on the chain, there's like prediction markets, there's things like Augur and Gnosis, there's various other like smaller ones that are getting released every week that I'm not even fully keeping track of. Like I'd obviously personally recommend like very deeply researching any of these before doing anything with them with substantial quantities of money, but like there is a fairly large space of things that's worth looking into. And obviously, if you're not just interested in kind of, if you're willing to go beyond just like stuff that's purely exists in crypto space, then there are like various projects and companies that you might want to look into. Yeah. Yes. Yeah. Yes. And so Raiden is definitely being developed, and there are a bunch of groups that are using channels. I think channels are a very cool and very promising technology, and like they don't offer just scalability; they also potentially have privacy benefits. But at the same time, you do need to know like it is important to know that they do have their own limitations. So, for example, in general, they work well for applications that are like between small groups of participants, but if you're thinking of something like an auction where like you're supposed to be able to let new participants join at any time, that's something that's like a bit harder to operate in a channelized way. So like there are situations that channels just like aren't really naturally that good for. There's also channels have their own unique security properties and security limitations. So like one of the attacks that I talk about is like there's two of them. One is that with 51% attacks, if you're just using things on the blockchain, 51% attacks can revert transactions and they can censor transactions. But if you have money in a channel, then with 51% attacks, you can also steal people's money. So, and another thing is that even without any kind of minor collusion, there's an attack where if you're a counterparty to a very large number of channels, you can like basically attack all of them at the same time, and there literally might not be enough space in the blocks in order for everyone to be able to challenge you before kind of the challenge period runs out and you could take their money. Now, I think all these problems are surmountable, but at the same time, like they are things that you have to think hard about, and like they are things that I think like you need to kind of really try and figure out how you're going to mitigate, like what your strategy is, like how exactly those issues, like interact with the way that you're designing your application and so forth. So I think like figuring out, making sure that that sort of stuff is safe is still something that's quite a while away. And obviously there's like peer-to-peer, like routing issues and all those other challenges. So, I think, potentially they could be, so channels as a technology, they could also be used as like a fairly low-tech form of privacy preservation. So like you could imagine two people like sticking their money into a channel, doing financial contracts inside of it, and then taking their money out. And it doesn't improve efficiency, but it improves privacy. You could also imagine, various any kind of like smart contract activity where you can kind of decompose it into kind of chunks that are each between small groups of participants. And like in a lot of cases, you can come up with fairly rich abstractions about like what kinds of applications those are. They don't always work extremely nicely. So like auctions are like one example where they don't work exceptionally well, but in some cases like they do work fine. And so like I know there's work being done for using channels for exchange. There's work being done on using them for like I think like the Lightning Network actually even is planning on being a decentralized exchange to some extent. So like I think that's also an interesting use case. And for like things like prediction markets, so, like a lot of those other applications tend to have an exchange component to them. So that also outside of channels, there's other kinds of like mostly off-chain kind of mechanisms. So interactive computation is one of the more interesting ones. And there's also kind of a few other smaller examples. I think like there's definitely lots of things that you can do with all of them. Although one of the drawbacks is that you do have to kind of think harder about how you fit your application into them. Okay. Yes. Mm-hmm. Yeah. So one way to measure how well the blockchain is doing is like, first of all, measure what percentage of the blocks are actually in the main chain. So like what percentage of blocks get forked off. Another thing you can measure is like with this PBFT kind of like finalization mechanism, how quickly it's happening, whether it's happening, how much of it is happening, how much safety you're getting. And I mean, another thing you can measure is like the kind of consistency between the finalization mechanism and the growth of the blockchain. You can measure like what portion of validators are getting or blocks are getting skipped. You can potentially can measure lots of things, and like actually I think what you can show is that there's literally only one way for a blockchain to proceed perfectly, right? At least in a proof of stake context. And from there, so you know what the maximum score is, and then from that you can measure deviations, or at least that's the general approach. Hmm. Yes. Hmm? Uh-huh. Some of your Ether were stuck in an ICO. Which ICO was this? Okay. Hold on. Which ICO was this? Tradecoin. Okay, so like, I would recommend going on Etherscan and like trying to look at the, yeah. Okay, so hold on. So like, if you look at the entry for the in the Etherscan for the transaction that you sent, what does it tell you? Like, no, I don't mean verify the code. Just like if you look at the Etherscan entry for the actual transaction that consists of you sending Ether to the ICO, like what kinds of things does it show? Like, did the transaction run out of gas? Did it actually end up transferring any Ether? Did you actually get any tokens out of it? Did anyone get the Ether? Right? Because like, in general, the Ether should either be refunded to you or it should belong to like whoever ran the ICO. And if it belongs to you, then you should be happy. If the Ether ended up in the hands of whoever ran the ICO, then you should like go and complain to them and like send them a nasty email and tell them you want your money back. Yeah. Yeah, like in general, I think it should be one of the two, because like if the okay. Okay. Yes. So on this topic, I actually have a few. Yeah, no, right. So like, I actually have a few kind of interesting ideas in this regard. So for example, one of my thoughts is that consultants in a lot of cases might not want to charge a fixed hourly rate because they might not know what their hourly rate would be. And so instead it might make sense for them to just say, I'm going to work for 5 hours a week and I'm just going to have an auction for those 5 hours. And like Ethereum is really good for running auctions. So like one of the interesting things is that you get really nice properties, like you get like guaranteed fairness, the thing works as intended. With ZK Snark technology, you can even potentially make the auction blinded. So, you could actually imagine these like smart contract mechanisms being used to kind of allocate those kinds of resources. I know I'm kind of mentally considering using it for like at least testing it out for like some small feature in some conference. Yeah. Yeah. Yes. Okay, so do you mean like if you're a validator? Okay, if you're with the latest version of Casper, that should not be the case. So, like, basically, you should be able to recover your Ether eventually, as long as you acted honestly, right? So, like, if you get hacked, then, like, basically, the attacker can obviously force you to do something dishonest and force you to lose your money. But, like, you can always get hacked and get your money stolen. So, outside of this, like, with earlier versions of the protocol, there definitely was, like, some small risk of losing your money if the entire protocol went crazy in some way, but the way that we're designing in the current direction is in such a way that, look, basically the only circumstance under which anything bad happens if you basically either like send an invalid message or you equivocate, so you like sign messages that mean two contradictory things. So that's like, if you don't do either of those two above, so if you just like run the daemon, then things should be fine, and like eventually you should be able to withdraw your money.
Okay, I guess that's all for today's session. So apart from the next meetup that we have with Bitcoin Singapore on 8th of February, there will be one on 22nd of February. It will be at SG Innovate, where Dr. David Lee, Lloyd Lui, as well as one technical developer from Digits will be speaking at. So happy Chinese New Year to all and happy holidays. Thank you.
David Lee says hi. I was just conversing with him, like there's some stuff that we're going to collaborate on. Yeah, how long are you here for?